Hi class, today we're talking about solving polynomial equations. So finally, all that factoring we've been doing is going to be put to good use. You'll notice on our page right now, I have GeoGebra up because we will be using it later in this lesson. So I encourage you to have that ready. You can just go to geogebra.org and we're going to be using something new in GeoGebra today. So you can leave that up for later, okay? So for now, let's go to the note. Our learning goals today are to define a polynomial equation and also what a solution is. Create polynomial functions based on given information. That's just within word problems. We're used to doing that. And then also, finally, solve polynomial equations by factoring, and also those that are unfactorable. And I'm going to show you guys how to do that using technology. So first of all, our first definition here, a polynomial equation. Just give me a pen. So that is just an equation in which one polynomial expression is set equal to another. Okay, so basically it's a polynomial equals a polynomial. So it could be something like x cubed minus 5x squared plus 3 equals 5. So this is a polynomial expression equaling a constant, which is a polynomial. Or it could be something like x cubed minus 5 equals x squared plus 1. Okay, so both sides have to be a polynomial, but now there is an equal sign. Okay, so think about what this would look like visually. Visually, this red one would be some cubic, however it looks. I don't know what it would look like. Okay, it's something like this. Okay, and you would want to know when it equals 5. So 5 would be represented by a vertical line at 5. Okay. But this blue one here, this equation means visually, so some cubic. Okay, when does it equal some quadratic? So there's the quadratic. Okay, so then visually, as we know, the solutions are just the points of intersection. So there could be 1, there could be 2, there could be none. Okay, it depends on the situation. But algebraically, that is the value of x, or the value or the values of x, or the independent variable that satisfy the equation. So visually, those are the points of intersection between the graph produced by the left side and the graph produced by the right side. So question 1, here we have, you'll recall, just a little like, recall previous knowledge. Okay, remember when you had stuff like this, x squared plus 5x plus 6 equals 0? Okay, so the way to solve this, a quadratic, is you could either factor or use quadratic formula. So quadratic formula, this is b, c, and a, you put it in. But factoring, this would factor to x plus 2, x plus 3 equals 0. So x equals negative 2 and x equals negative 3 are the solutions to this equation. Okay, so that means if you put negative 2 into this, you would get 0, or if you put negative 3 into this left side, it would equal 0. So the same thing is true with a cubic. We need to factor it. There's no such thing as a cubic formula like a quadratic formula. So the only way we know how to do this is by factoring. So this one can either be factored by grouping or by synthetic division. I'm going to show the synthetic division way just to refresh your memory, and then I can quickly also show you the grouping way as well. So we can take a look at what our factors would be, okay? So our constant is 3, so plus or minus 1 and plus or minus 3 are the integer factors. Then we would have plus or minus 1/4 and plus or minus 3/4. And then plus or minus 1/2 and plus or minus 3/2. So I'm hoping that I can find one of these, okay? So I go through and do my synthetic division, and I try stuff, and I'm looking for a factor, a remainder of 0 to show it's a factor, okay? So because I'm not actually teaching factoring here, I'm not going to go through the whole guess and check process. I'm just going to tell you guys that if you use, ding, 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 3, it will work, okay? So you get 4, 12, 0, 0, -1, -3, 0. So this works because you have a 0 remainder, whoop-de-woo. So then you have x minus 3 times 4x squared minus 1. So now we have to factor this, equals 0. Okay, so because this is an equation, you have to keep that equals 0. All right, so then this is just a difference of squares. So x minus 3, 2x plus 1, and 2x minus 1 equals 0. So now that's not enough. Now we actually have to give the solutions. So that means x equals 3, x equals -1/2, or x equals +1/2. And those are our solutions. So let's think about what those mean. Okay, that means if I put 3 into this left-hand side of the equation, or a -1/2, or 1/2, all of those would give me a right side of 0, or they would all equal 0, so left side would equal right side. So all of those values of x, all 3 of them, satisfy this equation. They make the equation true. Okay, visually, if you were to graph this polynomial, this cubic, these x's would be where the y value is equal to 0, or in other words, the x-intercepts. Okay? You can try this by grouping. How about you guys pause and try to factor by grouping first? So then you just get your, I'll start again with my 4x cubed minus 12x squared minus x plus 3. Okay, I'll do the factoring and then I'll see, oh, actually, let's set it equal to 0 now. So you group these two and these two. So take out a 4x squared bracket x minus 3 minus bracket x minus 3 equals 0. So then I'm left with 4x squared minus 1. Okay, remember there's a little imaginary 1 there. X minus 3 equals 0. And so then you get 2x plus 1, 2x minus 1, x minus 3 equals 0, and then you come up to the same conclusion. So therefore, x can equal plus or minus 1/2 or 3. Okay? So this is the most basic type of question you're going to be asked. This is when a polynomial is already set equal to 0, and so no rearranging is necessary. So that's the most basic type of question. You're just going to factor it and move on with your life. Now we're going to get to a word problem where you'll see there'll be a little bit more difficulties that come up. So Amelia's family, love that name by the way. That was one of my choices for a girl, but we didn't go for it. Amelia's family is planning to build another silo for grain storage, identical to those that they have on their farm. The cylindrical portion of those they currently have is 15 meters tall, and the silo's total volume is 684 pi cubic meters. What are the possible values for the radius of the new silo? Okay, so first of all, we need to recall a few things. The volume of a cylinder can be represented by pi r squared h. Okay, that's the area of the base and then times the height of the whole thing. And the volume of a sphere is 4/3. Oops, what's that? 4/3 pi r cubed. So we're going to need those formulas because a silo is just a cylinder with half of a sphere on top. So here goes my really bad diagram, which is going to be even worse on this trackpad than it would be on the board. Okay, so there's the cylindrical portion, and here's the dome on top. I'm sure you guys are all making fun of me right now. Okay, here's the front. Okay, so we can imagine a little radius here. Okay, and the height here is 15 meters from the top to the bottom. Isn't that just the best thing you've ever seen? So we're going to come up with an equation for the volume of a silo. So basically, the volume of the silo, so we can put volume equals, so we have pi r squared h, so that's the cylindrical portion, and then half of a sphere, so half 4/3 pi r cubed. Okay, so we have two variables here, h and r. So normally you can't solve for those, but we know that h is 15, so we can sub that in. We know that h is 15. So then we get the volume. Oh, and we know that the volume is 684 pi from the question. So we can sub those things in. So now we have 684 pi equals pi r squared bracket 15 plus, I'm just going to, 1/2 times 4/3 is 2/3, 4/6, which is 2/3, 2/3 pi r cubed. Okay, so this is actually a polynomial equation now because we have r cubed and r squared, and that's the only variable, right? Pi, remember, is just a number. So now I'm going to rearrange this for solving. Okay, so I'm going to change the order around a bit to 2/3 pi r cubed plus 15 pi r squared equals 684 pi. Okay, so now remember in quadratics, this is just a little aside. If you had like x squared plus 5x plus 5 equals minus 1, you couldn't solve it. The way to solve it was to put this minus 1 to the other side so that you had a quadratic equaling 0. So the same thing is true for polynomials. So what I got to do is get this 684 pi to the other side so I have some kind of polynomial equaling 0. That's my goal. Okay, I got to move everything over to the other side. So this means that I get 2/3 pi r cubed plus 15 pi r squared minus 684 pi equals 0. Now, so that's a constant because pi is just a number, it's not a variable. So I have this cubic function here, okay, where I have an r cubed, an r squared, no value for r, and then a constant. So I'm going to actually take out a value. I'm going to make this as simple as possible. I'm going to take out a common factor of pi over 3. All of these terms have pi in them, so it just makes sense for me to take it out. And I don't want this coefficient to be a fraction, so I'm going to take out pi over 3. So that means I'm left with 2r cubed plus, okay, now if I take out a third, that means I have to multiply by 3. So that would be 45r squared minus 2052 equals 0. Okay, so now I can solve this new polynomial by factoring. And or using technology. Okay, so because this pi over 3 is out front and this all equals 0, I can just divide both sides by pi over 3, and I'm just left with this 2r cubed plus 45r squared minus 2052 equals 0. And so now I'm just left to solve this. And I know you're thinking, oh my goodness, Mrs. Weens, there's like a million factors of 2052. How am I ever going to solve it? Well, think within the context of this problem, though. It's the volume of a silo, right? We're looking at that silo. What are the chances that the radius is going to be bigger than the height? Okay, does it make sense to have a wider base than it is tall? No. And you can also think about the fact that R also has to be positive. So there's no point in testing negative values because radius has to be positive. So we can test 1, 2, and you can figure out, is this divisible by 3? You know, you go through and see what it's divisible by. But you can only need to include positive values because the radius needs to be positive within this realistic situation. Okay, and you probably won't go further than a radius of, let's say, 10, because then already your diameter would be 20 and your height is 15. Okay, so realistically, in a situation like this, you're not going to get some crazy answer. So I'm going to, spoiler alert, I'm going to show what works here. So 2, 45, 0, you need that placeholder for the R, and minus 2052. Okay, so what works here is 6. 6 is going to work. So you get 2 times 6 is 12, and that gives you 57. 6 times 57 is 342. So that's 342. And 6 times 342 is 2052. So you get 0. So you have R minus 6, and then 2R squared plus 57R plus 342. Okay, at this point now, you can use quadratic formula. You do not have to factor this junk. You can use quadratic formula. Sorry, so this all equals 0 still. You got to include that equals 0. So I'm going to move this over here just because I'm not sure if that's behind my head. So you can just write quadratic formula. Okay, and that gives you the answers. R equals negative 8.6 and R equals negative 19.9. So both of those are inadmissible. I hope that's not behind my head, but it might be, sorry. So both of those are inadmissible. Okay, so therefore you can conclude that you need a radius of 6 to build the silo to spec. Okay, so how could you solve this using technology? Well, that's where we're going to go to GeoGebra now, and this is going to be your new favorite thing. So if, I don't know why that's coming up. Go away, there we go. Okay, go to GeoGebra Math Apps, and instead of graphing calculator, pick CAS. That stands for, no, I'm not sure what it even stands for. Something cool. Computer algebra system, maybe? Okay, so it should have this different stuff up top. So what you're going to do is put in your equation. So in this case, it's 2R, and then, oops, that's not R. Actually, I'm going to use X. 2X to the power 3, and then use your arrow button to get back down. Plus 45R squared, use your arrow button again, minus 2052 equals 0. Now don't press enter, press X equals. And there you go, that solved the problem for you. And for some reason, that's not giving me 6 as one of the answers. Maybe I should have tried this first. Did I enter it wrong? Okay. Oh, it's because I put an X and an R. Let's try that again. 2X cubed plus 45X squared minus 2052 equals 0. Okay, and then you press X equals. There you go. So here are your answers. So these two are from the quadratic formula, which would boil down to the decimal answers that I gave, but these are giving the exact answers, and then X equals 6. So you can also use GeoGebra to do this too. Isn't that cool? Of course, you can't use it on the test or the exam. Sorry about your luck, but that is another option for you if you just want to save some time, or if you're working on an assignment. If you can take a screenshot of this or something and show me your work, then that's acceptable as well. All right, so now we move on to question 3. The paths of 2 orcas playing in the ocean. They're recorded by these 2 different equations. They want to know when their height is the same. Okay, when are they at the same height or depth? So height can be negative here, but time has to be positive, and they only care about the first 8 seconds. So that's important. Okay, so you have to set these two equations equal to each other, which is a huge, long, annoying process of writing these out. See, and I'm writing way too big, equals, and then you write this whole long stupid thing. Oops, minus 200t squared plus 300t minus 200. Okay, so now you have this quartic equaling this cubic, and we want to solve for t. Okay, so we're let the heights equal each other, and we want to find the t values that are true when these two heights equal each other. So in order to solve something like this, you have to move everything over to one side, so you have some blah equaling 0. So that means I'm moving everything over. So I still have 2t to the power 4, and then I have minus 17t squared minus the 20t squared when I move it over. So that gives me minus 37, to the power 3, minus 37t to the power 3. And then 27t squared plus 200t squared when I move it over, so plus 227t squared. Okay, minus 252t minus 300t is going to give me minus 552t. And then 232 plus 200, so that's plus 432 equals 0. So I know what you're saying. This is insane. But remember that it's only looking for times within the first 8 seconds. So the only times that it's looking for would be 1 is a factor of 432, 2, 3, 4, 5 is not a factor. Oops, 5 is not a factor. But 6 is, 7 isn't, and 8 is. So you're only looking, remember, within the 8-second period. Okay? You also would have the fraction 1 over 2. Okay? That works because of the leading coefficient there. So 1 over 2 could be a possibility. 2 over 2, 3 over 2, and then those are all included. So there's 1, 2, 3, 4, 5, 6, 7, 8 possibilities for you to do with synthetic division. So I know it's a pain, but it's not as bad as it looks. Like that looks like a pretty terrible equation, but it's not as bad as it looks. So I will tell you that this factors to t minus 4, t minus 4, t minus 9, and 2t minus 3 equals 0. Okay, so you would go through your synthetic division, and 4 would work. Okay, that would be the first one here. So 1, 2, and 3 wouldn't work, but 4 would. And then you would go down to your cubic. Okay, I'm not showing this whole example because I taught this already last unit, so I'm just not going to make the video longer by showing that. If you need help with that, please ask me in class. It's really important. So therefore, the solution t equals 4 is admissible, and the solution 3 over 2 is admissible. T equals 9 is not admissible because it's not within the 8-second time period. So now you'd write a nice little sentence. Okay, finally, we have those polynomials that are not factorable. So how do you solve them? Well, there are some conclusions that you can come to using your knowledge of end behavior and exponents, especially if there are no solutions. Okay? However, if you do need to solve for an exact solution, you're going to use technology to do that. So this one, we can visualize what's going on here. So this guy is a quartic that opens up. Okay, notice that. It's a quartic that opens up. Its y-intercept is 0, 0. okay, if you put in 0. So it's something like, I don't know what's going on in the middle there. Some bumps might happen. But you'll notice that no matter what value I put in for x, it's never going to get as low as -1. Okay, oh, why is my pen doing that? It's never going to get as low as y equals -1. It'll never get down there. If I put a negative value in, because both of these exponents are even, it's going to come up with a positive number. So it's going to be some positive number plus 5 times another positive number. Nothing I put into this is going to give me -1. So there are no solutions to this. So you can do that even without factoring, just based on your reasoning. That can never happen. Okay? You can also use a graphing calculator. You can graph both sides. Okay, so if we go to GeoGebra here, and we go back to Math Apps and open up a graphing calculator, so we go into the normal graphing calculator as we're used to. I don't know why it's taking so long. No, do not. So if I graph y equals x to the power 4 plus 5x squared, okay, and then I graph y equals -1, we can see that they never intersect. Okay, so that's another option. We can also go into our CAS here and type in the equation x to the power 4 plus 5x squared equals -1 and press x equals. And you'll see that it says solve and there's nothing in there. That means there's no solutions. All right, so then our last example, this is solvable, but you'll find if you set up your synthetic division, 1, 0, -2, and 3, the only things you can try here are plus and minus 1 and plus or minus 3. So you can go through and you'll see that none of those work. Okay, so that means it's not factorable, but this reasonably could have zeros. If you think about it, there is going to be a spot where that equals 0, so that's when you have to use technology. Okay, so you can either use a graphing calculator, graph both sides and see where they intersect, or you can use our handy little CAS. So x to the power 3 minus 2x plus 3 equals 0. And then we press x equals to solve. And there is our answer. Sorry, ignore that. I don't know why I pressed it twice. Here it is right here. X equals minus 1.89. So that's our answer. Okay, I hope you guys liked this new GeoGebra discovery. Too bad we can't use it in a test or in an exam, but it does help you with some problem solving, and maybe will help you if you're trying to work on other parts of a problem besides just the algebra stuff. Just know that on a test or an exam, if I ask you to solve something, then it will be factorable. You won't have unfactorable ones on a test unless I specifically say, this is unfactorable. What can you tell me about it? Like question 4A, for instance. Okay, thanks for watching, guys. I hope you learned lots.